You've probably heard a ton about artificial intelligence and large language models, right? They're everywhere. But how do they actually work? Well, we're going to break it all down using a pretty simple and kind of funny analogy.
So let me ask you this. What on earth could AI possibly have in common with a parrot? I know, it sounds a little weird, but trust me on this. The answer to this question is the key to understanding some of the most powerful tech on the entire planet. All right, let's start at the beginning. We're going to build this whole thing from the ground up, and it all starts with one very, very clever bird. Okay, so let's imagine a parrot. We'll call him Buddy. Buddy lives in a house, and he's just soaking it all in. He hears every single conversation day in and day out. Now, here's the important part. He's not understanding what any of it means. He's just a little pattern-matching machine, memorizing which words tend to follow other words.
So, let's put Buddy on the spot. He hears his owner say this sentence, but they stop right at the end. Now, Buddy has heard phrases like this 1,000 times. What do you think he's going to squawk out next?
So what's going on inside Buddy's head? He doesn't know what food is. He doesn't know he needs it to live. He just knows, statistically, that after the words, "I'd like to have some," the word food is the most probable thing to come next. Cherries? Yeah, that's also pretty likely. Maybe he hears that a lot. But bicycle? The chances of that are almost zero. He's just playing the odds.
And that, right there, is the core idea. We actually have a name for this, a stochastic parrot. That word, stochastic, it's just a fancy way of saying it involves probability and a bit of randomness. It's the perfect description for Buddy, right? He's a clever mimic, just predicting the next sound based on what's most likely.
Okay, so we've got our clever bird. But how does this connect to the software you use every single day? Let's connect those dots right now. Check this out. The parallels are pretty wild. Buddy's training data is just the conversations happening in his one little house. A basic language model is the same, just trained on a specific set of data, like, say, all the Wikipedia articles about movies. Buddy mimics speech, the model predicts the next word. And if you've ever seen Gmail finish your sentence for you, yep, that's a simple stochastic parrot right there in your inbox. So we've got the basics down, but what happens when we scale this whole idea up? And I mean way, way up. This is where things get absolutely mind-blowing. Imagine our little house parrot, Buddy, suddenly gets a superpower. His training data is no longer just one family's chatter. It's everything. Every book ever written, every conversation on the internet, every website on the planet, the collected knowledge of all humanity. And that's the key difference. A basic model is kind of like someone who knows everything that's ever happened in one small town. They can make simple, local predictions. But a large language model, an LLM, has access to the information of the entire world. And that massive, massive scale allows it to do some incredibly complex things. With all that knowledge, our superpowered parrot can suddenly do things that seem, well, almost like magic. It can hold a conversation about ancient history, give you surprisingly decent nutrition advice, or even write a poem that's genuinely moving. This is exactly what's powering applications like ChatGPT. So how on earth does it handle all that information? Well, think of it like Buddy's brain getting way, way more complex. Inside an LLM is a thing called a neural network, and in some of the big ones, it has trillions of what are called parameters. You can think of these like tiny little dials and knobs that the model uses to track all the incredibly complex patterns in the language it's learned. But there's a pretty big catch. If our parrot is listening to everyone, it's going to hear some really bad stuff too. So, how do you teach a parrot with a superpower some manners? And this is a huge challenge, right? The internet has the best of humanity, but it also has the absolute worst. So if Buddy learns from all of it, he's going to start mimicking all the toxic, abusive, and biased language he's heard without even knowing that it's wrong. So the solution is this really clever process called reinforcement learning with human feedback, or RLHF for short. Basically, it works like this. You ask the model a question, and it gives you a few different answers. Then actual human reviewers look at them and rank them from best to worst. They tell the model, hey, this one was great, this one was a little unhelpful, and this one was actually pretty toxic. That feedback gets fed back into the model to retrain it. It's basically like teaching a puppy what's good and what's bad, over and over, until it learns to be much safer and way more helpful. Okay, we've seen what these models can do, and it is amazing. But it is just as important, maybe even more important, to understand what they are not. And this is probably the biggest takeaway of all. No matter how human it seems, an LLM is not a person. It isn't conscious, it has no emotions, it has zero subjective experiences. It can write a beautiful poem about sadness, but it doesn't feel sad. Everything it does, every single word, is purely based on recognizing and repeating the statistical patterns it learned from a mountain of data.
And that leaves us with this incredible, kind of mind-bending question. If we know that it's just a highly, highly advanced stochastic parrot, a pattern matching machine on a global scale, then why does talking to it feel so much like you're talking to something truly real? That's definitely something to think about.